Hey guys, let's take a look at number 3 of 2021 AP Chemistry free response question. So the question is asking guys, a student gives the task to determine the molar concentration of copper sulfate. Um, and student using the two different procedures, precipitation and spectrophotometry. So the first part, the precipitation part, right? So the student adds a 20 milliliters of barium nitrate and also some of the copper sulfate. And you probably will see that barium 2 plus and sulfate will precipitate, right? So and then they left it overnight, and then they provide you some data. So the mass of dry filter paper, volume of the copper sulfate delivered, and then such, okay? And A is asking, relatively simple question, right? A is asking guys, okay, write the net ionic equation for the precipitation of barium for the barium sulfate. So we know that guys, Ba2 plus is going to precipitate with the SO4 2 minus and turns into what? BaSO4. So keep in mind guys, you might want to make sure you put aqueous and aqueous and then sulfur there. Okay, make sure solid. I'm sorry. So make sure you guys put the phases there, and keep in mind guys here also as well that nitrate, which is NO3 minus, and copper, 2 plus, those will be considered as a spectating ion. Spectating ions do not get included into the net ion equation, so those are out. So that'll be the easy 1 point for number 3A. And part B of the question, guys, okay? Calculate the number of moles of the precipitate formed. Okay, so they're asking how many moles of the barium sulfate has been created. So to get number of moles, you have to get the mass of the barium sulfate and divide it by the molar mass. Okay, so how do I get the mass of the barium sulfate? So based on the data, you can subtract, okay, the mass of a filter paper from the data from the mass of the filter paper and the dried precipitate. So this is the mass of the barium sulfate. So yeah, basically the data is there. So you have to just subtract the mass of the filter paper and divide it by the molar mass of barium sulfate. Then you probably will get the number of moles of the barium sulfate. So I just put the data there, guys. Okay, 1.136 grams minus 0.76 grams. That's the mass of the dry filter paper. That's the mass of the filter paper and dry precipitate divided by the molar mass of barium sulfate. Then you get the answer as around 1.59 times 10 to the power of -3 moles of the barium sulfate. That'll be the answer of part B. In part C, the question is asking, calculate the molarity of the original copper sulfate solution. So understanding that, guys, where every sulfate, okay, has precipitated to barium sulfate, okay, which means number of moles of the barium sulfate produced is equal to the amount of the sulfate present before precipitation, okay? So if 1 mole of the barium sulfate precipitated, then what? They had 1 mole of sulfate in the solution, which means what? That means there is 1 mole of the copper 2 plus as well, okay? So now, understand that, guys. So yeah, so part C, right? Part C, I'm going to write it here, is they're asking for the molarity, so which is molarity is equal to number of moles of the copper sulfate divided by the volume. And because we understand what, guys? Yeah, that will be the number of moles of copper sulfate, okay? So by putting this, guys, so putting 1.59 times -3 divided by the volume, which is given as 0.05 liter, because they put 50 milliliters. The answer that I got is around 0.032 molar concentration of copper sulfate solution initially. So you guys put this as the number of moles of copper sulfate as we discussed, and volume is equal to 0.05 liters. That's 50 milliliters, okay? And that'll be the concentration for part C. Part D, so now part D, they're switching over to the spectrophotometry. So the question is asking, for the spectrophotometry experiment, student first to make a standard curve. Student uses a zero point 0.1 molar solution of copper sulfate to make a 3 more solutions of a known concentration, 0.05 molar, 0.03 molar, and 0.01 molar in the 50 milliliter volumetric flask. And part D, relatively straightforward question here. Part D is asking, calculate the volume of a 0.1 molar concentration of copper sulfate is needed to make 50 milliliter of 0.05 molar copper sulfate. So questions, this is a dilution question. So I want to talk about it where you probably want to use the equation as molarity. Okay, so molarity is equal to number of moles of copper sulfate divided by the volume of the solution. So you gotta understand, guys, okay? By diluting, what's being changed? You're changing what? So basically what I'm saying, guys, but you're pouring water into an existing solution by diluting. So what is really changing, guys? You're changing the volume of the solution. You're changing the concentration, which is molarity, but now number of moles of the copper sulfate that's initially present is not going to change. So what I'm saying is you have the beaker, and then you have some solution of copper sulfate in there, concentrated copper sulfate solution, and you're pouring water to dilute to have a lower concentration. So what is changing? Changing is what? Molarity and volume is changing, but the number of moles of the copper sulfate that's initially present is not changing. So now that becomes now you can set up an equation where it can cross multiply some molarity of the solution times volume of the solution is equal to number of moles of the copper sulfate. But as we know, copper sulfate number of mole doesn't change. You can change the volume and concentration but what happens? If you multiply those two, you can change it, but when you multiply the volume and concentration, that should still equal to number of moles. So the equation becomes molarity second, volume second, okay? So this should still be equal to the number of moles of copper sulfate initially present. That becomes an equation. M1V1 equal to M2V2. You got to plug it in. So we have a 0.1 molar concentration of copper 2+. We're trying to find out how much volume is needed when you try to create the concentration of 0.05 and the volume becomes equal to 50 milliliters. That's the equation, guys, okay? So you can put a molarity sign there. But if you calculate this, guys, the volume is needed is what? Around 25 milliliters of copper sulfate solution. That's the answer for second T of part D of number 3. And part E, the question is asking, briefly describe the procedure that students should follow to make a 50 milliliter of a 0.05 molar copper sulfate solution using a 0.1. So basically we're using this, okay? A 50 milliliter volumetric flask and other standard laboratory equipment. So they're asking, okay, explain how you're going to dilute a solution. So first thing that I would recommend you to do, guys, is just let's write out, guys, what we need. So we will probably need, as from what we did for the previous question, which is part D, right? So we would need 25 milliliters of what? 0.1 molar solution of copper sulfate aqueous solution. That's one. That's what we need. And also what we need as well, we also need to add 25 milliliters of what? Distilled water. Okay, so we have to add 25 milliliters of water and also 25 milliliters of what? Copper sulfate. I think the key part of the question is delivering exactly 1/100th of the milliliters of the copper sulfate and also the water. So that's pretty accurate measurements, right? So so first thing first, they said, oh yeah, so the total volume is 50, so we're gonna give you 50 milliliter volumetric flask. Okay, so then you have to add 25 milliliter of that guy and this guy, then that'll be it, right? But now, how are you gonna deliver not just 25, but what? 25.00 milliliters of the copper sulfate. So what can measure up to this 1/100th of the milliliters of the copper sulfate? So I think the question you have to use, so you have to mention that, okay, so I'll be using a burette. So burette or pipette can get you up to 1/100th of the milliliter. You cannot say graduate cylinder, you cannot say beaker because those are not accurate enough to give you this kind of measurement. So you probably would have to say that, okay, so first part, like in the first part, you probably would want to mention burette and deliver 25 milliliters of copper sulfate, which is, this is actually 1 molar, 0.1 molar solution, right? And then you put distilled water up to the mark of the volumetric flask. Okay, so that's the standard way to mention about part E. Okay, so you probably want to say, okay, so I would need a burette and measure out 25 milliliters of copper sulfate. You can say pipette as well, or you can say 25 milliliter volumetric pipette and then get 25 milliliters of the copper sulfate. That's 0.1, and deliver it to the volumetric flask, and then add 25 milliliters of water up to the mark of the volumetric flask. That is the direction you have to take for part E of number 3. Let's go to part F. The question, part F, it has absorbency and the concentration. It's a best fit line from the data they got. And it seems pretty good. All the points are on the dashed line, on the line, the best fit line. So part F is asking, the absorbency of the copper sulfate solution is unknown, of unknown concentration is 0.219. Determine the molarity. So I think there's a couple ways you can do this, guys. I'll tell you guys how I approach the question. So this is a best fit line, and they're saying, okay, so if the absorbency calculated is around 2.19, so you gotta find, like, you can draw the lines. So yeah, so this is like around 0.200, and if it's around 0.200, it's around 0.03 as the concentration, as molarity. Okay, this is a molarity here. This is absorbency. So you can I think one of the ways you can do is, well, you can sort of estimate where this value will be. So it's a little bit higher than that. So you can kind of estimate, okay, so what this value is based on a graph. And you can say that, oh yeah, so based on estimation from the graph, the molarity they're referring to is around 0.033 molar concentration. That's one way of solving this question, okay, for molarity of the solution based on the estimation from the graph. So if you want to be more accurate, then you can use the absorbency equation, which is a Beer's law, and try to estimate, what will be the concentration based on the absorbency provided here. So I chose a point, okay, around a 0.5 absorbency. So that one, it seems like it's right on that corner of the box, and it has absorbency pretty much about 0.08 as the concentration. So meaning absorbency is 0.5 and the concentration is 0.08. That's the best box where the line crosses. Okay. So now I came with the equation. So absorbency equation is what? Is equal to A times B times C. And for this particular question, A and B should be a constant value. A is absorbativity and B is the length of the light traveling, length of the cuvette. So these two are not changing. So only two values that are changing is the absorbency and concentration right now. That's why they're getting a straight line like this, okay? So now, basically, guys, again, based just like how the equation that we put in for the concentration equation, guys, these two are not changing, but A and C are changing. Absorbency and concentration is changing. So I'm going to put C on this side. So absorbency 1, concentration 1 is equal to AB, which is the value that is a constant throughout the entire experiment. So then this is equal to absorbency 2 divided by concentration 2. Okay, so these are known values. So when absorbency is 0.5, when absorbency is 0.500, concentration is 0.08. And now that's equal to, so they're saying absorbency is equal to 0.219. Then what is the concentration is what the question is asking. So if you solve, cross multiply solve this, I got the answer as concentration is equal to 0.035 molar concentration. So I think this is a better approach to solve a question than estimation from the graph. Okay, but I don't think you'll get the question wrong based on estimation from the graph. But still, like if you show this work based on the Beer's law, I think this will give you a little more accurate numerical value for the concentration for part F. Part G, the question is asking, a second student performs the same experiment. There are a few drops of the water in the cuvette. Cuvette is where you're putting the copper 2+ solution in there. And then the copper 2+ solution of unknown concentration. Will the result in the copper sulfate concentration for the unknown greater than, less than, or equal to the concentration determined by the part F? So if they have some water droplets in the cuvette before you add the copper sulfate solution, what's going to happen? So you are trying to make 25 milliliters, you should have added 25 milliliters of a 0.1 molar solution for, like, for example, part E, right? 25 milliliters of copper sulfate and 25 milliliters of water. But if there is accidentally you added more water, then what would the concentration? That's exactly where the question is going. So if there's more water than intended, then the concentration will be less. If the concentration is what unintentionally is less, what happens then? Absorbency should be smaller, and the concentration is what should be less. Okay, so if there were some water droplets in the cuvette, then expected concentration should be less because what? It will have a lower absorbency due to some droplets of water present in the cuvette. That will be the answer you have to put for number 3 for full points.